the way we build, while navigating us to a brighter tomorrow. Now we're bringing these two giants of tech together to create the next stage of computing, optimizing the data center for AI.
As businesses move faster to the future, it is critical for them to unlock the power of software and applications for every business to accomplish that acceleration. Applications are delivering insights, they're forging deeper customer relationships, redefining entire markets. Simply put, apps are becoming central to every business, to their growth, to their resilience, to their future. But we're at an inflection point for how applications are built, how they're designed. Literally, data is becoming the jet fuel for the next generation applications. But how do you take advantage of all that data? This key is AI. But who is the leader in AI today? Well, it happens to be my good friend, Jensen Huang, who's been leading, driving, creating this company called NVIDIA. Started as a little graphics company and now the world's leader in AI. Jensen, thank you so much for joining us for the special launch event inside of VMworld as we announce our partnership today.
I'm super excited to be here, Pat. And first of all, it's just always great to be at VMworld. This is one of the special events each year for the world's data center industry and for the world's enterprises. And so I'm delighted to be here. We've been working together for a very long time. And the announcement we're going to make today is really the biggest of anything we've ever done, and it's completely transformative for both of our companies. But I think the whole industry is going to be incredibly excited by the work that we're doing. Over the years, NVIDIA and VMware have built some really amazing things. One of the great things that we did was we virtualized the PC, virtualized the workstation, remoted it and put it into the data center, and made it available for anybody who wants to tap into it on any platform. And all of a sudden, what happened, the terrible things that are happening around the world, forcing everybody to work from home, the work that we did is really a lifesaver for designers and creators all over the world. Now they can continue to do their work from anywhere.
The COVID era has really put an unprecedented demand, literally the largest workforce migration in human history in just a few short weeks, leveraging this idea of video acceleration, and remoting of capabilities. It really has enabled so much of what we've been able to accomplish, and just amazingly, everything sort of worked, even as everybody went to remote work and work from home. Now, let's talk for a minute about the partnership, right? This is a pretty important day for both of us, Jensen.
Well, we're going to announce something really, really big. We're going to bring the power of AI to every enterprise. We're going to bring NVIDIA AI computing platform and our AI application frameworks onto VMware. Now, this is something that is really, really hard to do. And the reason for that is because VMware revolutionized data center computing with virtualization. However, AI is really a supercomputing type of application. It's a scale out, distributed, accelerated computing application. In order to make that possible on VMware, fundamental computer science has to happen between our two companies. And so it's really incredible to see the engineers working together. As a result of that, we're going to be able to extend the environment they currently have. Instead of building these siloed, separate systems, they can now extend their VMware systems to be able to do data analytics, artificial intelligence model training, all the way to scaling out the inference operations. AI is the most powerful technology force of our time. And these computers are learning from data to write software that no humans can. We want to be able to put all of this capability in the hands of all the companies so that they could automate their business and products with AI.
I love that, Jensen, making AI available, democratizing it for every enterprise in the world today. Yeah. That's what we're on a mission to do together. Right. And, as we think about this, in AI, it's 35, 40 years old, and all of a sudden it's burst onto the scene as this powerful tool. But how do we make it available for every business? And as we think about that, we think of three problems that we're working to uniquely solve together. First, how do we make it easier for developers, right? How do they build AI applications, AI, data analysis, machine learning, also high performance computing, highly related as well. Not only what they're doing in the cloud, but the cloud, the data center, and the edge, so that they can develop once and have it deployed across all those infrastructures, all of those solution sets, removing all the barriers, costs of specialized tools, infrastructure, systems, all as well, all on a standard framework. And finally, the issues of data gravity, right? These data sets are big, right? Do I have to move them to the cloud to be able to use AI? Maybe I need them high performance at the edge, right? So the issues of data gravity and also governance, and maybe I can't move all of my data out of my premise-based data center that we have as well. So these issues we're uniquely solving together, and we're doing it for all industries. We're building a horizontal platform for medical research, banking, financial services, retailers. It really is addressing the broad needs of making AI mainstream.
One of the things that's really cool is that AI is a whole new way of developing software. Data scientists are steering these powerful computers to learn from data to generate code. The process includes data processing, machine learning or training the AI models, and the inference deployment. This computing infrastructure is super complicated. Today it's GPU accelerated, it's connected by high-speed networks, it's multi-node scale out for data processing and AI training, and it's orchestrated containers for the deployment of inference models. Well, we've built an end-to-end AI computing platform and the AI software necessary for developers in domain-specific markets like healthcare, financial services, manufacturing, and others to use AI to create their AI models. We have 2 million developers.
That's incredible, Jensen. 2 million developers
2 million
now.
developers, 2 million developers and researchers using the NVIDIA AI platform, and the ecosystem is growing incredibly. It took us almost 15 years to attract the first 1 million developers on NVIDIA's platform. It took only a couple of years to double that. Yeah, this is really exponential growth, and it's really quite exciting. Today, we're announcing that we're going to bring the entire NVIDIA AI platform and the software necessary to develop AI on these platforms to the VMware Cloud Foundation.
And this idea of bringing that whole stack to the VMware Cloud Foundation, taking advantage of Kubernetes and Tanzu and what we're doing there, really is, we think, key to making this end-to-end enterprise solution available. And obviously the VMware Cloud Foundation, as we've talked about, is the most proven, broadly deployed cloud infrastructure in the world today. We've always been a CPU-centric company, right? And that GPU was always something over there. And maybe we'd virtualize, maybe we'd connect to it over the network.
Shame on you.
But now we're making the GPU. Thank you, Jensen. But today we're making the GPU a first-class compute citizen. And through our network fabric, through the VMware virtualization layer, it is now coming as an equal citizen in how we treat that compute fabric through that VMware virtualization management automation layer. And this is critical to making it enterprise available. It's not some specialized infrastructure in the corner of the data center. It's now a resource that's broadly available to all apps, all infrastructure, and the full set of resources can be made available. This is huge. And for every virtual infrastructure admin,
oh my goodness,
right? We have millions of people that know how to run the vSphere stack. They're running it every day, all day long. It's now the same tools, the same processes, the same networks, the same security is now fully being made available for the GPU infrastructure as well. A key piece, and again, solving hard computer science problems at the deepest levels of the infrastructure, mainstreaming that powerful GPU capabilities that you all have been working on so diligently now over decades. Another area clearly we're seeing that enthusiasm now is in healthcare and medical research. Right? And boy, if there's a moment in history where medical research and advanced breakthroughs in that area are important, today's the day as people are searching for vaccines. But also, this is some of the most confidential patient information, some of the crown jewels of businesses and pharma and biomedical research that's going on. So there's also great concerns over security aspects of that as well. So processing in the cloud and cost and data, movement associated with it. So this is another category that we're seeing huge interest in applying the most advanced AI breakthroughs. And again, NVIDIA and VMware are going to deliver AI for doctors and researchers, expanding the base for research around AI in healthcare. And with that, we expect to see all of these accelerations in our healthcare delivery being AI powered as we go forward. It really is exciting. And we add to that lots of other examples in retail and manufacturing. We really see that every enterprise, every segment needs to be fueled by data and leveraging the power of AI that we're going to deliver together, Jensen. I think we have a pretty cool demo that we're going to look at right now.
Distributed data analytics platforms like Spark are being used in data centers everywhere to perform AI training and data processing. These platforms require a scale-out approach on multiple nodes in order to perform efficiently. This scale-out approach lends itself well to an accelerated virtualized environment. VMware has optimized vSphere to enable these applications to take full advantage of GPU acceleration with GPU Direct RDMA, maximizing accelerated compute and networking capabilities from NVIDIA hardware and software. Leveraging the power of accelerated virtualization, we easily deployed an 8-node Spark 3.0 cluster as virtual machines, accelerated by NVIDIA A100 virtual GPUs and NVIDIA Mellanox NICs with GPU Direct RDMA. This cluster can be used by data scientists to analyze data and train models. Here we're training a model using XGBoost to predict breast cancer occurrences using a 240 gigabyte dataset with over 30 features. VMware's integration with NVIDIA results in AI and ML capabilities that are accelerated faster than ever before. With Spark 3.0 on VMware, combined with NVIDIA GPUs and networking, we can train our model for this dataset 31 times faster than a non-accelerated cluster. This means that a data scientist can iterate on new data and retrain their model many more times in a day, dramatically increasing their productivity. Next, let's see how modern workloads take advantage of GPU acceleration on VMware's cloud-native ecosystem. VMware Tanzu will support GPU-accelerated containers from NVIDIA NGC. Here we're showing how NVIDIA's Clara SDK can be deployed from NGC on VMware Tanzu and be used by clinical researchers to perform AI inferencing on imaging data. NVIDIA NGC is a repository of GPU-optimized containers, Kubernetes Helm charts, deep learning models with pre-trained weights, and Jupyter notebooks with sample code. Using VMware's Tanzu on vSphere, an IT administrator can easily deploy Kubernetes clusters for modern cloud-native applications and developers. Further, with NVIDIA's A100's virtual multi-instance GPU capability, each user can even further divide a single GPU and provide access to dedicated GPU resources for their work. Once the cluster is provisioned, we can easily pull the Clara Deploy SDK and an AI COVID-19 classification application directly onto the cluster from NGC. We can then activate a pipeline to process 3D CT scans and classify them for COVID-19 probabilities. The pipeline takes the full dataset consisting of DICOM images, applies a 3D lung segmentation model, followed by a COVID classification model, and produces a 3D volumetric image in seconds. Here is the finished result, a fully interactive 3D volumetric rendering of the lungs.
That was an incredible example of AI at work, and we're going to have so many examples over the next several years together. Jensen, I think you have one in particular that you like a lot that you're working with.
Well, UCSF is one of the top research hospitals in the United States. Their Intelligent Imaging Center is using NVIDIA's Clara AI algorithm and AI platform to do groundbreaking research in advanced radiology. UCSF is VMware and NVIDIA's customer. Let's take a look at this work.
The Center for Intelligent Imaging at UCSF began last year. It's an initiative to focus on the development of clinical artificial intelligence technology for medical imaging applications.
We're working on diseases actually across many different organ systems. We are looking at applications directed at brain tumors. Ultimately, we will cover every organ system and diseases as we have expertise. In this department, we actually have expertise across all the organ systems.
Now, AI algorithms, as we all know, are so data hungry. So the modern state-of-the-art GPU is absolutely necessary for medical imaging data.
But going beyond that, the finer features in an MR image, if you wish to use those features in a data-driven way, the issue goes beyond computational power. It really depends on the memory available. So in addition to computational power and GPUs, we have a need for GPUs with a lot of memory and doing things with very, very rapid input and output times so that it can all happen much faster.
Systems like VMware are absolutely essential in the distributed system in which we work. We need to be able to review data remotely. We need to be able to ensure that data are stored securely. We need to be able to plug in to large computational engines across large geographic distances now.
Once we actually have a really robust model, our plan is to have an inference server on the VMware platform so that we can actually get the data from the scanner, run the inference, deploy the models to the radiologists at the PAC station, but at the same time knowing full well that the full potential of AI will only mean that we have to increase our footprint with regards to the number of inference servers, the time that they all run, etc. We want a scalable model, and hence we went to the exploring VMware.
I can't imagine a more impactful use of AI than healthcare. The intersection of people, disease, and treatments is one of the greatest challenges of humanity, and one that AI will be needed to move the needle. I can't wait to put AI to work in every doctor and every scientist's hands. NVIDIA AI on VMware Cloud Foundation is a big deal, but we have more to announce.
We do have more to announce. The market's demanding these more and more sophisticated applications, cloud-native applications, larger data sets, more bandwidth requirements, lower latency, 5G we're building out. All of these is demanding a new architecture yet again. And a couple of years ago, we started Project Pacific, and we said we're going to put Kubernetes right into the core of vSphere, and today that's shipping and broadly available. Well, today we're announcing the next big re-architecture of vSphere, Project Monterey. It's not just CPUs and GPUs, but also taking advantage of the powerful capabilities that are now in the network, smart NICs, or the DPU, as you like to call it. And Project Monterey is a fundamental re-architecture of vSphere that will take advantage GPU, CPU, and DPU that enables security, that enables high-performance network offload, that will enable us to fully distribute the network security model in a zero-trust approach, and enable VMware Cloud Foundation to not only manage CPUs, but also bare metal computers, fully stretched across the network from the cloud to the data center to the edge.
Pat, you're absolutely right that the data center is going to get re-architected. All of these new workloads, the AI workloads that are coming into the data center, is going to drive a reinvention of the data center. The data center today is software defined, it is open cloud, it is running these AI applications that are in containers spread out all over the data center. The networking workload, the storage workload, the security workload on the data center is really quite intense. And so we need to reinvent the infrastructure, continue to allow it to be software defined, secured, and disaggregated, but yet it has to be performance, has to be scalable. So we're super excited to partner with VMware on Project Monterey. The characteristics, the pillars of Project Monterey of offloading the operating system, the data center operating system onto the smart NIC, isolating the applications from the control plane and the data plane, and accelerating the data processing and security processing to line speed is going to make the data center so much more powerful, so much more performant. The processor we invented for this is called the Nvidia Bluefield Dpu. It's built on the Mellanox state-of-the-art, industry well-known high-performance NICs. The Bluefield Dpu is going to essentially take the operating system of the data center, networking, storage, security, and virtualization functionality, and offload it onto this new processor. This new processor is going to be essentially the data center infrastructure on a chip. It's going to be really exciting. Data centers are going to be much more performant as a result of this.
As we think about the challenges of those next generation applications, big data sets, high bandwidth requirements, low latency, but also security requirements as well, and being able to take full advantage of the resources of the GPU, CPU, and the DPU, as you call it, truly enables an end-to-end security model, zero trust security, increasing complexity of this environment being reduced into the infrastructure software and silicon that we provide, and breaking down these traditional models and silos in the data center, but not just in the data center, but the cloud, the data center, and all the way to the edge. That's what Project Monterey offers to the market in the future.
Pretty exciting stuff.
Project Monterey combines VMware Cloud Foundation and NVIDIA Bluefield Dpu to accelerate networking, storage, and security services for high-performance hybrid cloud workloads. Let's take a close look at how the combined solution delivers improved threat detection, protection, and remediation for a high-performance distributed application. Here, two developers on distributed teams are working in real time on a high-throughput streaming app that uses NVIDIA Omniverse. Frequently used by enterprises that require real-time collaborative rendering and visualization, such as manufacturing and product design teams, performance and collaboration must be optimal and in sync to be successful. Watch what happens as a DDoS attack occurs. On the left side of the screen, Dave's server is running on VMware's cloud infrastructure deployed with NVIDIA Bluefield 2, while Jay's server on the right side is operating in a traditional architecture. As the cyber attack progresses, Jay's server chokes, flooded with packets. His work is interrupted, making it impossible for him to continue collaborating with Dave. Dave's work, on the other hand, continues seamlessly. So what's just happened? The combination of VMware Cloud Foundation and NVIDIA Bluefield 2 has mitigated the cyber attack on Dave's server. The DPU recognized and dropped the rogue packets in real time, shielding Omniverse from the attack. The solution delivers intrinsic security distributed on every server for better protection at a lower cost of ownership. Together, NVIDIA and VMware are delivering the ideal solution for modern enterprise hybrid cloud for next-generation high-performance apps. The security and flexibility of software-defined control with optimized efficiency and performance.
That was an incredible demonstration of some of the early work that we're doing in Project Monterey, Jensen. And we're just getting started, right? Yeah, this is just some of the early offload works and some of the early security works, but we think this is just opening up an entire re-architecture of the distributed data center. This is part of the value of the VMware NVIDIA relationship. And, it was so fun when we started this discussion as well. I called you up and we said, hey, how about this? And you said, well, how about this? Right? And you just blew the doors off of some of my vision for what we might do together as we sort of went from, crawling to walking together. And you said, let's just go into a sprint. Yeah. And with what we're already working on, right? We just think there's so much that we can be doing together as we simply reshape the architecture of the data center, of the cloud, and the edge.
Yeah, Pat, this is just so incredibly exciting. And because VMware is the operating system of the modern data center, we also have to reinvent all the things that VMware is able to do, from virtualized monolithic applications to scale out bare metal computing, still virtualized, all the way to containers that are orchestrated. This way of doing computing is going to be the way that the future data centers are built. It's going to allow us to essentially turn every enterprise into an AI. Every company will become AI driven. It will be AI augmented. And every data center of our companies will be the brains. And so I think this collaboration between us and VMware is just such a privilege. And it's so much fun for the two of us to go and reinvent the computer industry. And so I can't wait to do it.
Well, Jensen, decades of relationship with you. And today, I think, is the most exciting day of the relationship that we've had. And our audience is so excited to be able to see how we're coming together to make everything that they've done for the last 2 decades of VMware, right? Now it's just going to be even further expanded as well. Jensen, thank you so much for joining us today.
Terrific. Thank you, Pat.